Good day. In this final lecture, we go to chapter 5, plotting in Matlab. And this is not tested, but you may need this for your project too. 5.1 Basic XY plotting. When you have a series of data, X values and Y values, plot XY is just a plot of Y versus X. You can add grid lines by adding this command, grid. X label text will add this string on the X axis as a label. Of course, Y label text will add this string to Y axis. Of course, you can add both by putting X label, Y label. For two series of data, x1, y1, x2, y2, you get a double plot on the same graph. Of course, you can include legend, the keyword is legend. String number 1, string number 2. String 1 is for the first pair of data series. For the second pair is legend number 2. For example here, we want to plot y equal to sine x in the interval between 0 and 2 pi radians. So, let's say x from 0 to 2 pi radians, increment of 0.2. So x is going to be 0, 0.2, 0.4 up to 2 pi radians. And for each value of x, we're going to calculate y. Y is sine x. So y is going to be a vector the same size of x. So for each x, we have a corresponding value of y equal to sine x. Plot xy, label x-axis just as x, y-axis as y, grid on. If you don't put this grid, there's going to be no grid. Default is grid off to get this plot. We can also choose the color of line and the type of line. For example here, plot xy. The first character is color, it's black. Second character is going to be, in this case, solid line. So doing this, we get this plot, solid black line. But we can also use, instead of solid line, we can use symbols. For example here, plot xy, black, K is black, P is pointed star. So you get this plot of black pointed stars. Or you can combine both solid line and symbols. So here, but you have to do it twice. Here, let's plot xy, black pointed star. The second time around, black solid line. Without the dash here, it's going to be by default solid line. These two are equivalent. Of course, you can switch. This can be here, this one can be here. Any order. So you get both solid line and symbol. Additional commands and plot types. Subplots. On a single graph paper or single page, you can do many plots. For example here, the subplot M and P. M refers to the number of rows of plots and number of columns of plots. P is the pin or the slot where you want to do the plotting. So here we have, let's say, X series, and for each X, of course, we have Y equal to sine X. Subplot 2, 1. It means that in this single page, we have two pins. 2 times 1 is 2. 2 rows of pin in a single column. So in pin number 1, we plot SY. So you get this, sine X. Second plot, of course, Y equal to cos X. Subplot in pin number 2. So just below it, we plot Y equal to cosine X. Data markers and line types. This is just a basic plot, solid line. This is going to be data marker. No color. Color is up to Matlab or TIFF. Here, solid line. Here, second plot with data marker. Here we plot SY. Green, the symbol is asterisk. And for the same series SY, we plot red dash lines. So for the data markers, the second character here, you can use any of these symbols. For line type, any of this. For the first character is color. So color, you have to refer to this table. K for black, B for blue, and so on. When you have, for example, more than 2 plots on the same graph, for example, here we have S1, Y1 series, X2, Y2 series, different function. One is sine, the other one is cosine. Even the intervals are different. So in this case, we plot the first series, Y1 versus S1, Y2 versus X2. Of course, we just put the label there, S label, Y label. But here we do not know which function is which. To make it easier, you can use legends. So for the same example above, we can add legend. For the first pair, we want to put legend sine x. For the second pair, of course, this is cosine x. So you can put any string here and then they will appear on the graph. So you get this. Of course, here we only have symbols, no solid lines. So these are the legends. Of course, you can combine solid line and data markers. Some specialized plot commands. Bar xy will produce a bar chart. Of course, y versus x. Log means the x and y axis are log 10 scale. Plot y, so the first pair is going to be plotted based on the y axis. On the left, the scale will refer to this pair. On the right, the y axis will refer to this pair. Semi-log, of course, only x is here, log scale, y is linear. Here semi-log y is log scale, x is linear, stats and stem. 3D plots. So you can do 3D plots. But before you do that, for your vectors, row vectors, you must convert to matrices. Let's look at this example. Let's say plot z. Z is a function of 2 independent variables given by this equation. In these intervals, x between 0 and 3 radians, y between 0 and 4 radians. Of course, if you have to look at in tabular form, this is what it looks like. X values 0 to 3 radians, y values 0 to 4 radians. Of course, for each x and y, we have the z value in this table here. So how to do a 3D plot? For this x row vector, this is these values, but in row vector form from 0 to 4 radians. Now, you have to convert these vectors to matrices, capital X, capital Y. You can use any symbol here, for example, AB. I'm using capital X, capital Y. For the transform small x and small y. So the keyword is mesh grid. You have to generate the grid. In other words, for example here, the grid is going to be 0, 0. Here it's going to be the grid point here, 0, 0 0.1. Here, 0, 0 0.2. This is what the function of this mesh grid. To generate a pair of xy values at each intersection of x and y. Then we calculate the z value here, this function, but using the transform variable, not the original variables, but the transform variable. So here sign capital X, of course element by element, because the calculation are done element by element, in other words for each grid point basis, plus cos x dot capital Y times capital Y. It's an element by element operation. For mesh plot, of course, mesh xy z, capital xy z, this capital Z here. So you get this plot. X from 0 to 3 radians, y 0 to 4 radians into the z value. So you get the mesh plot. You can also get mesh z. Basically you have a vertical lines here. Waterfall, basically you have slices along the y-axis. Let's say z is not a function but tabular data. So for each, for example here, x and y we have z values. So the same process, x136, y2469 row vector. Z is just these values, matrix 4 by 3. Transform this and this to capital X, capital Y. Generate matrices X and Y. Now just mesh X, Y, Z. So you get this plot. And you can check for each value of X, Y, the intersection you have the Z value in this table here. Just very quickly, I'm going to demonstrate this. So going to the Octave compiler, let's say if you have x values 0, 0 0.2, let's say up to 10. Let's see y is just x, remember dot, because element by element operation. This is power 2. So for each value of x, we have a value of y. To see if you want to see the x and y values, let's say I want to create a table, just tap the new, just a matrix, x transpose. So I'm going to convert this to column vector. The same as y transpose. And these are the x and y values. Of course, you just type x, you get this output in row formation. I'm going back to the original x and y values. So plot that's why you get a solid line y versus x. The color here is determined by Octave or Matlab. Of course, you can put label there, x label. Y label. Of course, this is with grid. So grid is on. Of course, you can file, you can save as. It's going to be figure. Of course, you can copy this window, this graph. Just right click here. So control print screen. For example, you want to copy to your a blank Word document here. Control C, so Control V. Copies everything. But you can crop. Crop this into a nice figure. You can enlarge this. Because let's say centered. There you have your figure in Word document. Going back to Octave. You can also specify the type of line. For example, black. This is going to be black solid line. It doesn't appear. Sometimes you have to go here. The figure is here because I forgot to delete the old one. So just tap click here. So black solid line. It can be red, just red solid line. For example, you can use also K is black, P is pointed star. This is symbol only, no solid line. If you want to combine both solid line and symbol, you have to repeat. For example, K, this is pointed star. I have to repeat the plot XY, black, solid line. Now I have both. Pointed star and solid line, both are black. What if you have multiple plots on the same graph, just like your project number 2? Let's say you have x1 0 to say 0.2 up to 5. y1 is x squared, x1 squared. Second series, let's say x2. I'm just putting in different n values. Let's say here to 7. y2, let's say x2 to the power 2.3. Plot s1 y1, x2 y2. Plot the first series and the second series, both on the same graph. But here you don't know which is which. To differentiate between the two, you can put legend. Legend. So there's going to be two of them. One is two of them, two strings. So for the first pair, s1, y1, x squared. For the second one, the second pair, x2, y2, is x to the power 2.3. Now I have the legend here. It's a lot clearer. This is for x squared, this is for x power 2.3. awkward here. And of course, you can add text. You can insert text. Just go where you want to add the text. Just drag, left click. So here, this is where you add the text. For example, this one is, y is equal to x power 2.3. Of course, I can go down here and add text for this curve. So they have two options. You can add text or you can use legends. Three plots. Let's say I have x equal to from 0 to increment of 0.2 to pi radians, small y, from 0 to, let's say, 0.4 to 2 pi radians. Let's say the function is z equal to sine x multiplied by cosine y. So what I want to do is transform this vectors to matrices capital X, capital Y using mesh grid. So mesh grid, that's why. Because you can use as a symbol, for example, A here, B here. So A is for small x, B is for small y. Now my function z, that's capital Z, sine not the small x, but the transform x. It has to be element by element operation. Cosine y. See, the original function z equal to sine x multiplied by cosine of y. So for the grid points, you have, for each pair of x, y values, we have the z value in this matrix. This matrix is the same size as x and y. You have three matrices, x, y, z. Let's say I want to create a mesh plot. Mesh, capital X, x-axis, y-axis, and the z values, capital Z. So we don't get the labels. We should put the labels. For example, x label. I'm just putting x here. It can be any string. Y label. Z label. Of course, you can simply just put Z there. I want just to put this equation here. This is a string. So for this plot, this is x from 0 to 3 radians, y 0 to 4 radians is the z value. Of course, you can use this, click this button, you can rotate to get the best view of the 3D plot. Because there are many types of plots, 3D. I can do mesh C. So below I have the contour, combination of mesh surface, contour at the bottom. Can also be mesh Z. So you have vertical lines parallel to the Z axis. You can also have solid rendering. For example, using the arrow key, go to the previous command. Okay, home. Surf. Surf is for surface rendering. So I have surface rendering. Mesh is without rendering. Surf can be combined with contour. Contour at the bottom. Waterfall is basically 3D plot with slices along the y-axis. So you have slices along the y-axis. Okay, that's the end of Matlab. So don't forget, on the 22nd of January, 9 to 10:15 a.m., you have your test number 2. Thank you.